So for those who don't know me, my name's Mark VanGessel. I'm the Extension Weed Specialist at the University of Delaware. I'm located down in Georgetown at the Research and Education Center. And when I was asked about different topics for the pest management section, I was trying to think of different ones, and I kind of hesitantly threw out the idea of maybe doing something on cover crops with our weed control part of it. And I'm glad I did. It gave me an opportunity to kind of go back over the years of the work that we've done and start to pull it together. You know, with the interest in this last year with the NRCS and the year of the soils and the big, about a year ago there was a big USDA conference on cover crops and so on. And I got asked at that point about, you know, what are we doing for soil health? And I thought about it. Initially I said, well, we're really not doing much on soil health. We're doing cover crops, you know, and my focus on cover crops had been almost exclusively what is the weed control, what the aspects of weed control related to cover crops, and haven't been measuring a lot of these other benefits associated with cover crops. Not to say that what we're doing doesn't bring these additional services and so on cover crops, but it's just something that we haven't really focused on much in our research. The other thing about cover crops and giving a talk like this to folks, particularly when I'm used to, you know, giving a lot of recommendations and stuff, is cover crops for weed suppression, for weed control. There's a lot of factors that all rely upon one another. And so making recommendations and utilizing cover crops for weed control is going to be very different from one person to the next. And so as you maybe explore this topic a little bit more, keep in mind about where you're getting the information from. Is it coming from New York, Ontario, where they have a much shorter growing season than what we've got? Is it coming from the South, where they have a longer growing season? You know, are they talking about using cover crops after silage corn or after grain corn? You know, are they growing their cover crops on, you know, clay loam soils, or are they growing them on sandy loam soils or loamy sand soils that don't have the water holding capacity that we have? So it's important to kind of take in mind and consider where the information is coming from, what is their objective of using the cover crops, and under what conditions are they growing the cover crops, as you try to interpret the results and maybe put them into practice for yourself. Before I get too far along, I do need to thank the folks who I work with. I get to stand up here and talk, and my name usually goes on the program, but it's Barb and Quentin that are doing much of the work behind the scenes. Also, I want to acknowledge Bill Curran. Bill has done the most work on cover crops in this region. He was gracious enough to supply some of the slides and some of the photographs. I've been on a number of projects with Bill working on cover crops in the last few years. And some of the folks who have worked with Bill there, John Wallace, Claire Keene, Matt Ryan, and Stephen Mirsky. So I'm going to talk about cover crops, and again, focusing on cover crops or weed control or weed suppression. Some of the considerations of high biomass cover crops and how that might impact cash crop management. I'm going to finish up talking a little bit about managing cover crops, maybe not specifically for weed control, but how that impacts weed control. And then talk about some of the projects we have ongoing in this area. If you have a question or a comment, I have no problem if you shout it out and raise your hand and kind of cover it as we're going through it, instead of waiting to the end when you probably will forget it like I would. So I have no problem if we make this a little bit more discussion oriented. I did a search on the internet of various websites looking at what are the benefits or the uses of cover crops. And you can see it's a pretty healthy list. Everything from improving soil fertility, reducing the need for pesticides, improving soil health, help safeguard personal health, It's a source for grazing, improving soil tilth, and ultimately improving yield potential over time, increasing organic matter over time. There's a lot of benefits of what, or reasons for planting cover crops. And that's why I said early on that we have been focusing on cover crops for suppressing weeds and haven't necessarily measured for some of these other benefits associated with cover crops. In our area, this is kind of a list of fall planted species that are often grown as cover crops. I know a lot of people joke you don't see chickweed on the list, but these are the non-weedy cover crops, or well, we'll get into that in a minute. But earlier planting dates, some of the earlier planted ones that need to plant earlier in the spring, in the fall: spring oats, Austrian winter peas, rape, forage radish or tillage radish, forage turnip. Some of these that can be planted later in the year, they have a wider window of planting, optimum planting time. Our winter grains, triticale or triticale, crimson clover, hairy vetch, annual ryegrass, or kale. So there's a number of different species that are commonly discussed here as options for cover crop. And because a lot of our cover crop is being used as a nutrient management tool to scavenge excess nitrogen and phosphorus, a lot of times we forget about the summer cover crops. But some of the species that are available and that we've worked with over the years: buckwheat, sun hemp, sorghum Sudan grass, cowpeas, or red clover. Some of these cover crops will likely winter kill, although not always, like the spring oats, the tillage radish, with a few very cold days of approximately 20 degrees for 3 or 4 days. A lot of these will die, but if we don't have the right type of winter, a lot of these are going to survive. And a couple years ago was a great example where a lot of the tillage radish did not winter kill and needed to be killed or terminated come springtime. As I mentioned, Bill's done the most work in the area on cover crops. He's put together this nice little pamphlet that's available on the internet, suppressing weeds using cover crops in Pennsylvania. Used a lot of this. It's a nice resource. It gives a good starting point. And again, because of so many interrelated factors in terms of using cover crops for weed control, like many things, it may not have the specificity that you're looking for. If we think about an annual weed and its life cycle of starting from a seed in the seed bank to germinating, that white thread stage, seedling, vegetative growth, and then reproduction and producing seed, we have the cycle here, and here are some of the different characteristics of cover crops that may impact that life cycle. Starting with that seed in the seed bank, the cover crops affecting the microenvironment, the soil moisture, the soil temperature. Cover crops enhancing maybe some of the soil pathogens and insects in the soil, which might be seed predators, and destroying seeds. To when it starts to germinate, the physical suppression, which might modulate the temperature, the potential allelopathy with some species. And again, altering the temperature of soil moisture as that seed starts to germinate. Enter that white thread stage. When it's a seedling, growing as a small plant, the competition of the cover crop, growing side by side with it. Again, allelopathy. Possibly the cover crop is dead and it's dried biomass and serving as a physical suppression for the growth of that seedling. So cover crops can impact the life cycle of an annual weed at multiple stages in its life cycle and through multiple processes. So weed suppression by cover crops. We can get weed suppression through direct competition. And as a weed scientist, you've heard us talk a lot about weed competition and how weeds reduce the growth of our crop, reduce yield. Well, that goes both ways. That cover crop can suppress these weeds If the cover crop is planted with a compatible life cycle to the weeds, thinking of like cereal rye that's planted in the fall, competing with winter annual weeds like common chickweed and henbit, that cover crop is gaining the advantage in terms of early growth and suppressing the growth of the weeds. Intercepting light nutrients, interfering with the growth of the weeds. That cover crop can be killed and serve as a mulch layer that interferes with germination establishment of weeds, particularly if that mulch is thick enough and remains intact, and may prevent the germination. This physical suppression is generally more effective on smaller seeded species than larger seeded species. Things like morning glory and common ragweed, not as sensitive to cover crops as things like ragweed, as pigweeds or some of our grass species. Cover crops can release chemical compounds referred to as allelochemicals that inhibit weed growth, particularly seedlings, before they get established. This whole phenomenon is referred to as allelopathy. Not all cover crops have allelochemicals. Some do. Rye is one of those that is well reported to have allelochemicals.
What weeds does rye have allelopathy over?
Mostly some of the small seeded species. Trying to some of like chickweed, henbit. Now, the one thing about allelochemicals is that the concentration of allelochemicals vary with the stage of the plant, and so I'll leave it at that because I'm going to get myself in trouble because it's not off the top of my head. But at different stages, there's different levels of concentrations of allelochemicals. So if it's killed, if the rye is killed at different stages, they may have different concentrations of these chemicals. A lot of these chemicals are also very water soluble, so excess rain will quickly leach them out of that soil profile. So while it happens, it's documented well in the laboratory and in the greenhouse. Under field situations, it's one of those things that's hard to count on. It's not as far as relying strictly on allelochemicals. It happens, but it may not be something that we observe very readily in the field. And then the final one, before we've got a cover crop planted. We planted it for any of those other benefits, whether it's nutrient cycling, nitrogen fixation, water infiltration, what have you. But we're managing that cover crop and we go in and terminate it. That termination process can have an impact on our weeds and contribute to overall weed control and weed suppression. So as a talk, competition, particularly when the cover crop is planted, a cover crop with a very similar life cycle to the weeds is planted, it becomes more of just a competition for resources, competition for light, moisture, nutrients. Although it's not documented, I wouldn't be surprised if some of these situations where we have a very thick cover crop compete for carbon dioxide as well. Remember, plants do need carbon dioxide. A lot of things go into this how successful plant competition is. Having a cover crop that's going to have rapid early growth, it's very important. The plant architecture, how does that plant grow? The development of the root for capturing nutrients and moisture, and plasticity, the ability of the cover crop to adjust to the environment it's growing in. Here's a picture. The top photograph here is cereal rye. On the bottom we have spring oats, planted at the same time. They're about the same height, but one of the things to notice about the cereal rye, it's basically shading the complete soil surface at this point. It grows more of a low, sprawling growth habit. It always looks to me like it's a plant that someone stepped on. It's kind of a ragged growth to it.
They both drilled?
They were both drilled. Yep, they were both drilled. And you compare that to our spring oats, which we can still see soil surface there. growing more of an upright. So the success of the competition depends a lot on the plant architecture as well. Yep. As far as cover crops as a physical suppression, a mulch, kind of some of the direct effects, the cover crops impact soil moisture. It can lower the soil moisture, not as much sun as, soil temperature, not as much sun radiation is hitting the soil surface to warm it up. The cover crop can reduce the amplitude, the difference between day and night temperature. That temperature differences can have an impact on germination of some of our weed species. So reducing that difference can reduce germination, reduces the amount of light that hits the soil. Some of our species do need light in order to trigger germination. It can help hold soil moisture and may release allelochemicals. We're relying on mulch for weed suppression. You know, we want something that's going to stick around as long as possible. Species that have lots of leaves and fleshy stems to them decay quite rapidly. Compared to something with more mature stems that contains higher levels of cellulose and lignin and don't break down. They remain intact over a longer period of time. So if you're looking at something that's going to provide physical suppression of it, looking at species that are taller growing, thicker stems, woodier stems, or tougher stems, if you will. Rye is a great example of a species like that. Rye, once it starts to elongate. How much biomass do we need in order to really help with weed suppression? This is a trial done with Chuck Moeller and John Teasdale of the USDA, where they looked at different levels of rye and its impact on the establishment of different annual weeds: velvet leaf, lambsquarter, dock, dandelion, chickweed, witchgrass, and pigweed. Looking at the yellow bars there, it gives us the number of weeds per meter, number of seedlings per meter, if there was no rye biomass, no rye mulch. But if looking at about 5,000 pounds of rye and the reduction in many cases of the number of seedlings per meter square, lambsquarter dropped considerably, pigweed dropped considerably. Lambsquarter and pigweed, both small seeded species that are sensitive to these physical mulches. Velvet leaf didn't see much of an impact. In fact, really needed to get up to about 7 to 8,000 pounds before we saw a reduction in velvet leaf. And velvet leaf is one of those larger seeded species that's not going to be as impacted by biomass mulch. What can we do to manipulate cover crops to improve weed suppression? Whether we're talking about more competitive cover crop or growing large amounts of biomass to provide that physical suppression. Considering species selection, something that's rapid growing, particularly if you're looking at competitiveness, something that's going to be more rapid in its early part of its vegetative life cycle, getting it established within the optimum time so you get that rapid growth. When are we going to terminate it? How much biomass are we going to get produced at the back end? What seeding rate do we need? Row spacing? And do we need to consider soil fertility in order to develop or grow a competitive cover crop or produce enough biomass to provide weed suppression? Nice thick cover crop like this in March, if we're looking for weed suppression, is really what we're looking for. This is a trial that was done by Stephen Mirsky up at Penn State a few years ago. Stephen's now with the USDA in Beltsville and has continued a lot of this cover crop work. But what we're looking at here is a series of slides that were taken on April 1. This is up at State College, so northern PA. But photographs were taken on April 1 of plots that were planted on August 25th, September 5th, September 15th, all look about the same as far as row cover and at least visually biomass production on April 1. But if planting date was delayed till September 25th, October 5th, or October 15th, we're starting to see a reduction in biomass and the amount of ground cover there. So planting date can have quite an impact on how much growth we get out of those cover crops. Again, this is up at State College, so based on down here having done a number of trials with these guys up at State College, they've got we're about 2 weeks difference on either end of the growing season compared to what they see. Looking at that same data set, where they have the same planting dates, August 25th through October 15th, they killed the cover crop at different times. They killed it May 1, the bottom bar, May 1, May 10th, May 20th, and May 30th. One of the things to kind of note is the shape of these curves, or the slope of these lines, is similar across all the different termination dates. What this is telling us is that planting 30 days earlier in the fall gave us about 2,000 pounds additional biomass. The other way the other way of looking at it is delaying our planting date by 2 weeks reduced our biomass by about 2,000 pounds. On the other hand, delaying our termination from May 1 to May 30th increased our biomass by about 6,000 pounds. So delaying planting by 30 days in the fall reduced biomass by 2,000 pounds. Delaying termination by 30 days in the spring increased biomass by 6,000 pounds. Our rye cover crop is more responsive to termination dates than it is to our planting dates in the fall. Now, how does that translate to its impact on weeds? So here we had no rye. This is the number of Lambsquarters per square meter. With no rye, we're up to about 45 Lambsquarters per square meter. If I should mention, our termination date in this particular example is May 1. So all terminate on May 1, but if we had delayed our planting as late as October 15th, we are about 25 Lambsquarters per meter squared. September 25th to October 5th, we're down to about 15. And while these earlier planting dates are not significantly different, you see there's a trend towards reduced density with those earlier planting dates. So for successful weed suppression with cover crops, we're looking at least 4,000 pounds to really have a noticeable impact on weed densities and weed suppression. We did a project with Bill up at Penn State, Stephen at Beltsville. We were down at University in Georgetown looking at different cover crop systems for grain production. We were looking at a single planting date, but we had 3 different termination dates. We were looking at hairy vetch and triticale, which got planted in early September at all of our sites. It was terminated by the first week of May, or starting in the first week of May. And you can see at all of our sites we got at least 4,000 pounds of biomass. Delaying that till mid to late May, we were well over 6,000 pounds per acre with triticale and hairy vetch. Cereal rye, which got planted later in the fall, and again terminated early to mid-May. You can see in most cases we were well over 5,000 pounds with cereal rye at these 3 different locations. So the point here is we are able to produce high amounts of biomass throughout this region. There's a lot of questions, a lot of interest in planting mixtures as well. Putting in multiple species, more than one. Some of the things you need to consider when you're thinking about multiple species. One, starting off, what is your objective? What are you trying to achieve with these cover crops? Are you looking at alleviating compaction, soil structure, weed suppression, what have you? As opposed to starting with what cover crop should I plant, you should start off with what is the objective of using that cover crop and selecting the cover crop accordingly. The other part is matching up your cover crops, making sure that the cover crops are going to be compatible with one another. If they don't have the optimum planting window, one of those two cover crops is going to suffer. When's the best time to terminate them? And particularly for anyone who's looking at this from an organic standpoint and trying to terminate their cover crop with like a mechanical roller crimper, terminating it, termination time is very narrow and very specific. It's as the as the plants start to develop flowers, when they're at full flowering. That's about a 10 to 14 day window for these cover crops. If they don't match up, go in and roll it once, you may kill one of the cover crops, but not all the cover crops in the mix. So consider life cycle of the cover crops and whether you're going to be able to, plant them so that they're both within that optimum planting window, and you're going to be able to terminate them together as well. But some of the mixed species, they complement each, do they have complementary growth periods? Do they mix well with plant architecture? We've done quite a bit of work with the legumes like hairy vetch or crimson clover with a grain crop. They work out really nice together. The grain crop provides an upright structure where a lot of that vining from the legume can get more biomass because it's growing up the stems of the triticale or the rye. Mixing cover crops so they perform different functions. Putting a nitrogen in with something that's scavenged, something that might alleviate compaction. So mixing and matching depending again on what is your objectives for that particular field.
Question.
Yes?
Has anybody ever done any work with how many GDUs chickweed or henbed or Lambsquarters takes to get out of the ground so you can time this better?
You did. I feel like you did.
We've done on some of the species germination period. Bill Curran and one of his students a few years ago, we looked at some of the summer annuals. We haven't done much on the winter annuals, but we were looking at lambsquarter, pigweed, ragweed, foxtail.
So somewhere it's written down how many GDUs it takes to emerge?
Yes, I can see, if you want to see me afterwards, I can show you a paper that we've published on that with specific GDUs. There is a publication or an extension fact sheet out of Iowa State that gives it in relative terms. But if you're looking for specific GDUs, you have to kind of go to the scientific literature to find that.
Does that guide to help decide when to burn down a cover crop?
Not necessarily. No. I think there's too many other overriding considerations for burn down than basing it on specific GDUs of the weeds. Better factor is if you're trying to have an impact on those weeds, to ensure that you spray it before the weeds flower. Because we're not looking at residual control out of these products. We're looking at of our burn down products. A lot of times we're looking at glyphosate and paraquat, which have no residual activity. So we're looking at killing what has emerged. And spraying them in the spring, all these winter annuals have already emerged. And being sure that we spray them early enough that we impact seed production is going to be important for our long-term management. Any other questions? Yes.
As we're looking at the cover crops or the cover crop mixtures for suppression weeds, many, you talk about how much biomass you need. You have that broken down into seeding rates, or how many plants per square foot?
Do we have that broken down by seeding rates? And no, we don't. Because that's good. If you're looking at biomass production, there's a lot of factors that go into that. And probably termination timing is more critical than some of these other factors might be.
Mine's more of a planning your cash crop question. As we try to get our cash crop planted, say corn, 1st of May, end of April, where you don't really get the biomass or the ground cover, these cover crops. So, which is more important, planting later and getting more biomass, or killing early when you don't have the biomass?
Let's hold off here about planting cash crops. I'm going to talk about that and some of the issues of planting cover crops, which may answer that question better for you.
Okay.
Because a lot depends on your equipment as well. And we'll talk about that.
Okay.
What are you able to plant through? All right, so establishing cover crop. So we're looking at 5,000 pounds as a minimum for weed suppression. That's a lot of biomass out there trying to plant through it. Typical no-till equipment often will not handle that much biomass. We need a lot of weight. One of the things that we've done with our planters to plant through this high biomass is add as much weight to as we can. We usually make sure, we're planting relatively small equipment, 10-foot row plots, making sure all the bins are full with as much seed, the liquid fertilizer, whether we're putting the liquid fertilizer out or not, that's full of water for weight, that may even need to put tractor weights across the bins to add more weight to the back. Being sure that the coulters are sharp, they're not dull, they're not worn. Coulters that have a straight edge do a better job than wavier coulters because there's less surface area for penetration. And then making sure that you have one that and that those coulters are set deep. One of the problems, it took us 2 years to figure this out, that we weren't setting our coulters deep enough. And it wasn't cutting through that residue like it needed to. We've got to put as deep as we can. It's going about 3 inches into the soil, but needed that in order to cut through that residue. Are you getting good closure of that seed slit after you've planted? That becomes more important, particularly if you're using soil-applied herbicides that prevents that herbicide from coming in direct contact with the seed. Are you able to do that, get that with your planters? Do you plant standing rye or standing cover crop, or do you roll it down first? Anyone's been working with high residue cover crops here? Okay. Dan, are you planting and then rolling it down? Are you getting it on the ground and planting through it? How are you handling that?
We plant right through. We don't have rollers. We plant right through. We have row cleaners, but it's problematic.
The row cleaners?
Well,
the whole thing.
Right.
Yeah.
And we're talking about green beans too, so it's not.
Oh, okay.
So we have emergence issues.
Yes.
She's got a buddy in PA that's got attachments on the front of the planter for his row cleaner. You've probably seen it, Lucas Criswell. They were specifically made, I think, for John. He was one of the first to kind of test run with it. Really good results. Get it in the ground.
Is that row cleaner then creating a 2 or 3 inch band of open soil then? Yeah. So that's the other issue. Do you want to do that? If you're relying on your cover crop to maximize weed suppression, do you want to move that cover crop away from the seed, that row, and provide lack of physical barrier for it to come through? So you set up of your planter is going to be very different if you're in a situation like this with a fair amount of residue, but all dead, all dry, and you're using row cleaners to clean that row, as opposed to maybe planting into a standing rye, may dead or may be dead, may not be, but planting into a standing situation, or some of the more sustainable organic systems where you're rolling that rye, planting into it, and you want as much of that rye over the seed as possible to provide weed suppression in the row. All that has a big impact on how do you have your planter set up and manage that. Did that address some
I
of
was
the
thinking
questions?
more of a timing. My question was, the later you suppress or terminate your cover crop, the more biomass you get. Say May 30th, but we plant our crops typically end of April, 1st of May, so you don't have that biomass. So which is more important, planting earlier or getting more biomass and planting later? Which is more beneficial?
And it
Profitable.
Well, it comes down to profit. Okay, so if you delay that planting, so you get more biomass, now you're kind of going to a shorter season hybrid, possibly.
Possible.
Do you take a hit on going to a shorter season hybrid as a result of that? What's the objective of your cover crop? Are you looking at it from a weed control standpoint? If you are, I would say that letting it get larger and more biomass there is going to help you with overall weed control than going in earlier and terminating it.
Well, I would do it more for moisture retention and keep the ground cooler, would be my main goal. But then if you plant later, you get your pollination period more during the hotter time of the summer. So. And
again, I think if you're looking at moisture conservation and soil temperatures, probably don't need as much of a residue cover as you would if you were looking at it from a physical suppression of weeds.
Okay. All right, thanks.
This is a project we did at the University of Delaware this past year. It was funded by the Delaware Soybean Board. We're looking at 3 different factors and how they might interrelate for weed control. We're looking at levels of rye. We were hoping to get no rye. We planted the whole field to rye in the fall, and that went in early spring and sprayed. We're going to spray a third of the plots out with glyphosate. We didn't get as good a control as we were hoping for, so it has pretty low levels of rye while we were hoping for none. Then we had no spring nitrogen, and then we had plots that got about 40 pounds of nitrogen in the spring. So we truly did have 3 levels of rye. We had a burn down where we used glyphosate alone, or we used glyphosate with Envive. Envive is a combination of Valor, Classic, and Express. We chose Envive just because it's a product that many people are using. We could probably have a number of different products that fit into this scenario. And then our burn down timing was either 20 days prior to planting, early pre-plant, or 10 days before planting. So we were planting into a dead cover crop in this situation. Looking at the amount of rye biomass that we were able to achieve, if we used a little nitrogen in the spring, we were well over 10,000 pounds of biomass. We were able to get 8,000 pounds of biomass with no nitrogen, but we had to delay our burn down we planted on May 20th, so this was burned down on May 10th. So we still got quite a bit of biomass with no nitrogen, but delaying that burn down. Compared to if we had burned it down on May 1, we were under 4,000 pounds. So that extra 10 days made a big difference in the amount of biomass produced in this field. Looking at some of the different weed species we had, the morning glory, well, nothing was great for morning glory. We did get better suppression if those burn down treatments were applied 10 days prior to planting as opposed to 20. Again, Cover crops didn't have much of an impact on morning glory. It's a large seeded species, not very sensitive to cover crops. Palmer amaranth. We had an interaction between our levels of rye and our whether we used Envive or not. I should say that this site did not have ALS-resistant pigweed, which may have altered our results a little bit. But anyways, regardless of the rye level, if we used a residual herbicide, we got excellent control at 5 weeks after planting. If we did not use a residual herbicide, we saw a stepwise increase in control with our levels of rye. We were up to over 95% control with just high rye biomass by itself, no residual control. Annual grass, which was primarily March crabgrass, the main factors were all significant. We had better better crabgrass control if we sprayed closer to planting or burned down closer to planting. We got better control if we used Envive compared to glyphosate by itself. And again, we saw where the presence of the rye gave us better annual large crabgrass control than low or no rye. And as I said, not all cover crops. We think of cover crops oftentimes in regards to summer annual weed control. They can have quite an impact on our winter annuals as well. And it's a different phenomenon again. The winter annuals planted with a winter annual weeds planted with a winter annual cover crop. We're looking at plant competition. This is a trial I did a number of years ago with mare's tail or horseweed, looking at no rye, 30, 60, and 120 pounds of rye planted. In all cases, the presence of the rye cover crop reduced the density of horseweed compared to bare ground. Now, the increase in the seeding rate wasn't always consistent across the locations. But again, the presence of the annual ryegrass the presence of the cereal rye, so it happens when you give two talks back to back, it's getting before lunch. The presence of the cereal rye did a nice job of suppressing the horseweed. So summary, up to this point, cover crops are used for many different reasons, including weed control. A competitive cover crop during a fallow period in the fall makes nice sense in that we're not exposing bare ground throughout the winter, and there may be some financial incentives for doing it as well. The presence of the cover crop can have an impact on our winter annual weeds through crop competition. The physical weed suppression of summer annual weeds is possible, but it requires a fair amount of biomass, a minimum of 4,000 to 5,000 pounds per acre. And it may not fit with all farm management systems and may require some specialized equipment for planting the cash crop. So using cover crops for weed control should consider all the different scenarios, what your crop rotation is, your herbicide management, and are there while there's a lot of interrelated factors that make a successful cover crop program for weed suppression or weed control, if those factors all don't line up, do you have alternatives for controlling weeds later in the season? So again, we think about cover crops for weed suppression. What's your species? Is it going to be compatible with your cash crop? When can you get it planted? What seeding rate should you use? What's the optimum planting method? Do you have enough fertility there for growing that cover crop? Because now it's not just cover, it's a crop. And you're managing it more as a crop. A lot of questions about herbicide carryover, particularly as folks look at planting their cover crops earlier and earlier in the fall. A lot of labels do not address cover crop herbicide carryover to cover crops. If you're not harvesting that cover crop and feeding it either to animals or consuming it, rotational restrictions based on herbicide residue is not an issue for you. It's whether that herbicide is going to injure and suppress the establishment and the growth of the cover crop. There's not a lot of good data on some of the crop safety, and it's been a little bit of a moving target. A year ago, we did a project, looked at planting different species over multiple herbicides. When we evaluated the cover crops in mid-September, this past spring, I got asked by a lot of folks about, well, can I safely plant certain cover crops on August 15th or earlier? That's 4 weeks earlier than what we had evaluated them. So it's going to take a while for us to develop data sets that we feel comfortable with for recommending some of these rotation restrictions. As I mentioned, mixtures, consider the species, consider the ratios. You know, the two pictures on the left at the top is rye plus 20 pounds of hairy vetch. You can see there's quite a bit of vetch showing up in there, whereas at the bottom we got 90 pounds of rye and 10 pounds of hairy vetch. If you're growing corn after this cover crop and you're wanting that nitrogen, this 60 pounds of rye and 20 pounds of hairy vetch might be the mixture you're looking for. However, if you're looking for weed suppression, there's a lot more stems and plant material that's going to be resistant to breakdown with that 90 pounds of rye and 10 pounds of hairy vetch. So consider your ratios of what you're planting based on what your objectives are. As mentioned, talked a little bit about herbicide carryover. Last fall we planted cereal rye, forage radish, and crimson clover across a number of our plots. Overall, the cereal rye was very tolerant to all the herbicides we were evaluating. They were the common corn herbicides and soybean herbicides. The radish, though, the forage radish or tillage radish, was the most sensitive. It was sensitive to PPOs, things like Valor, Authority, Reflex. We often saw this type of browning, necrotic tissue along the veins on radish with those herbicide carryover. First rate, also we saw stunting with crimson clover and forage radish. Question is, you know, what's your objective with the cover crop? Can you tolerate a little bit of stunting? Or if you're looking at maximum biomass, maybe not. That's something that you need to consider. When to terminate your cover crops? As I mentioned, it's particularly critical if you're using mechanical means like a roller crimper. You want to make sure that if you're planting cover crops, certain species that you terminate them before they produce seeds and they can become a problem. You know, I often joke, if you buy it and plant it from a bag, it's called annual ryegrass. If it grows in the field, it's Italian ryegrass. It's the same species though. So if you plant annual ryegrass and it all goes to seed, and you're planting wheat, now you're dealing with Italian ryegrass next year in that field.
How long we got before the cereal grains are Roundup resistant?
Well, hopefully a while. The cereal grains, hopefully a while. Well, I'm not aware of anyone, but that I'll jump to another point then. One of the things that we've done, you know, we're trying to kill these cereal grains. We're trying to kill hairy vetch, all these cover crops, when they're 2-3 feet tall, maybe 5 feet tall, okay? Have you ever heard a weed scientist say you should spray a herbicide on any plant more than 3 inches tall? Yeah, we always say small, susceptible plants. So now we're trying to kill cover crops on large plants. And we're putting an awful lot of faith on these products performing under those situations. So be careful.
So that's the bane of grain producers right now. We're all this cover crop, and then in spring we gotta kill it, but sometimes it doesn't want to die. Right. From when you get it and you've got a lot of cover, your time is going to be what it is.
Right.
So, recommendation. What are your recommendations for killing cover?
What's your cover?
Small grain.
Small grain? I've had very good luck with glyphosate for killing rye, all of them in the spring. Now, I usually spray glyphosate by itself and not tank mix it with anything, and then maybe make a second application for it, because you're asking an awful lot of, you're hoping that there's no antagonism or no type of interaction with multiple chemicals. So I usually spray glyphosate by itself, particularly early spring, just for that. Also, recommendation is do it while we're talking about large biomass here and stuff. Leave yourself some time, that making sure that it's dead or well on its way down before you plant, because if you don't and that catch crop comes up, your options for killing that cover crop are greatly reduced. And I know there's lots of talk, I shouldn't say lot, I know folks have talked about planting green, planting into a standing cover crop and then spraying it and killing it. I'm not going to say don't do it, but go lightly on it and work out a system that works for you, because not only are you spraying a large cover crop, you're spraying it after it's been damaged from the planting operation, and you're asking an awful lot of those chemicals to kill it. A lot of the brassicas, the glyphosate's not very good on the brassicas. 2,4-D is a better option for killing those brassicas. Paraquat and whether it's atrazine or metribuzin, paraquat with a triazine herbicide is fairly broad spectrum for a lot of our broadleaf weeds as well. This is a trial we did last year on annual ryegrass. We looked at 2 different varieties of annual ryegrass, a brown bag that I got from the local hardware store, and then a branded variety. We sprayed glyphosate on April 27th. We used 22, 27, and 32 ounces of glyphosate. And in almost all cases, the branded variety died more. It was easier to control than the brown bag ones. There might be some differences in varieties response as well with annual ryegrass. We added glyphosate at 22 fluid ounces with Valor and with atrazine. And notice here, this branded variety with just glyphosate at 22 ounces was over 80% control. We added Valor to it, and it dropped to about 65% control. Again, it gets back to the point of be careful about tank mixing. Better to split that application and go with straight glyphosate or your burn down herbicide and come back later with your residual product. Relying solely on a cover crop for weed control requires a lot of factors to be successful. Now, with the way a lot of our cover crops are being used, particularly for nutrient management, scavenging excess nitrogen, and I used to, kind of before I put this talk together, was thinking, well, those cover crops really aren't helping us with weed control. But, the fact that a lot of our cover crops are under government programs, can't add additional nitrogen, can't add phosphorus to them, they've got to be terminated at least later than March 15th, but a lot of them are being terminated fairly soon because they don't want the cover crop to get rank. But what that means is we're spraying those cover crops fairly early in the spring. We're spraying them while those winter annual weeds are small and susceptible. We're spraying horseweed when it's still in the rosette stage, not 12 inches tall. We're spraying the red stem fillery and the primrose while it's 2 to 3 inch rosette, as opposed to 6 inch rosettes are starting to flower. So while we're not spraying that burn down, that herbicide to kill the winter annual weeds, we're spraying it to terminate the cover crop, we're getting benefit out of it in terms of our weed suppression. So managing a cover crop in terms of the termination date indirectly is helping us in some cases with our winter annual control. Oftentimes there's not enough cover crop biomass to provide weed suppression for summer annuals, but I think in many cases it is helping with our winter annual management. some of the winter annuals being chickweed and Italian ryegrass. Just some of the projects we have ongoing in this area, started in the last year or two, looking at integrating cover crops to help with resistant biotypes, herbicide-resistant biotypes. How best to integrate high residue cover crops with herbicide management. How does cover crop impact the performance of soil-applied herbicides? You got 2,000 to 4,000 pounds of biomass out there. How much of those soil-applied herbicides that we're applying is getting to the soil surface? Are some soil-applied herbicides more, do they wash off that residue easier than others? It might be the things that we want to consider under those scenarios. That's something that we're starting to look at. Again, looking at herbicide carryover to these cover crops, particularly as we start planting them earlier and earlier in the fall. Most of the interest in cover crops over the years has come from the organic community. It's now moving into conventional systems. If we're looking at biomass for weed suppression, we're looking at least 4,000 pounds of biomass. As we get further north, probably on the lower end of that biomass is what we need. As we move south, we need higher levels of biomass. Success is going to depend on the weed species and the severity and on the cover crop selection. So, with that,
We're going to say thank you. You've had great questions along the way. Some people really want to go to lunch. For those who want to ask questions, come attack Mark. How about that? Thanks.
Thank you.